Hi, so in this video we're going to work out the volume of a cone. Now cones will usually used in engineering and design, and if you visit mathswrap.co.uk that will give you quite a lot of detail and information on why cones are used and other forms of 3D shapes. You can also subscribe to the YouTube channel and have a look at the playlist on volumes of 3D shapes, and that will give you quite a lot of information. So with this particular video we're going to be looking at a cone shape, and you can see with the cone that we have a vertical height, and also it's actually, although this is a little bit of paper, but it's actually a circle at the bottom. So the clue is really we need to know what the area of a circle is, and then we also need to remember the formula for how to work out the volume of a cone. Well, actually the good news is if you're taking GCSE, this formula is actually written in the front of your exam paper. However, it is as well to learn this formula if you can. Okay, so the formula for the volume of a cone is 1/3. Okay, I'm going to make sure I'm checking my notes so I've got the same as everybody else, times the area of the base times the height. Okay, now a couple of things really with this. I've written it out like that because when you see it in your exam paper, it's going to say 1/3 pi r squared h, which is exactly the same, because if you just look at pi r squared on its own, well, pi r squared is working out the area of a circle, and as we said before, it's a circular base. So pi r squared is the area of the base. It's multiplied by 1/3, and then it's multiplied by height, and that will give you the volume of the cone. So let's just have a look at a practical example, and this is from a GCSE question. It's actually an A grade question. So if I draw the picture that we have here, we've got the cone. Okay, and the cone has a perpendicular height, which is this overall height here to the base. So I'm going to draw that in there at a right angle, and the perpendicular height is 12.5 centimetres. Okay, so that's very important because we need to know the overall height. The other thing we need to know is the radius. Well, the radius of this cone is 6 centimetres from the centre there to the outer edge. So 6 centimetres radius and 12.5 centimetres perpendicular height. And actually that's all the information we need in order to work out the volume. The two ways in which most exam questions will come about is they'll actually ask you to work it out to maybe 2 or 3 significant figures or decimal places, or they might ask you to leave it as a value of pi. Now, the reason that is because pi is a fixed figure, or certainly for the purposes of these sorts of calculations, normally 3 decimal places is perfectly fine. Okay, so we'll just work it out as a value of pi first, and then we'll work it out using the calculator to get the overall volume of the cone to a degree of accuracy. Okay. So the first thing I'm going to look at is I'm going to look at the formula, and I'm going to put my numbers into the formula. So the first one is 1/3 pi, and then r squared is radius 6 centimetres, and it's 6 centimetres squared. So in other words, it's 6 centimetres times 6 centimetres. Sometimes I think it's really useful if you do leave it as 6 times 6, because sometimes on exam papers I see people writing 2 times 6, which would be 12, which would be quite different to 6 times 6, which is 36. So it is definitely r squared, or 6 times 6. So if you try and write it in like that, I think sometimes it's just a little bit easier. Okay, and then the overall height is 12.5 centimetres. And as I'm doing this, I'm just checking that it's centimetres each time. That just makes it a little bit easier for the calculation and to make sure the calculation is accurate. Okay, so we've got 1/3 pi, and then 6 times 6 times 12.5. Okay, well, 6 times 6 is 36, and then 36 times 12.5. Now, usually these are on calculator papers. So I'm just going to use my calculator to work out that calculation there. So on this, it's 36 times 12.5. I don't know whether you can see that on the video. Maybe you can if I put it about there. So 12.5 is 450. So it's 1/3 pi times 450. Okay, that's pretty good. And actually, when you look at these, generally speaking, the figures should work out fairly well for you, because 1/3 times 450 is 150. So in order to answer this question to a value of pi, it would be 150 pi. So that would answer the question for the volume of the cone in terms of pi. Okay, and also I think if you see the numbers are coming up and they work out relatively straightforward, then it will give you some indication that you're on the correct track. And you can see that what I've done there is I've worked it through very logically all the way through, and that will give me that volume. Just for the sake of this particular video, what I'm also going to do is I'm going to multiply 150 by pi, which I'm going to use as 3.142. And again, that's a value that's usually given on the exam paper. So if I want to know an exact amount, or at least an amount to 3 decimal places, it would be 150 times 3.142, and that's going to be 150 times 3.142. You can also use the value of pi on your calculator as well, but usually in these questions they will give you the value. But if I multiply that, and hopefully you can see this on the video, that would give me a value of, or actually 471.3. Okay, so those are my two values. The only thing I need to remember to do is to put my unit value in place, because I think with these sorts of questions, particularly grade A, if you don't put the unit value in, then you're quite likely to lose a couple of marks. With these type of questions, there usually may be 4-mark questions, and 1 mark will probably be allocated for making sure that you write centimetres cubed in there and centimetres cubed in there. So those are my values. Those are my values to answer this question for the volume of this particular cone, with a radius of 6 and a perpendicular height of 12.5 centimetres. I hope that's been useful to you. Please do visit mathswrap.co.uk. There are some worksheets that you can download and have a go at for yourself. You can also subscribe to the YouTube channel and have a look at the playlist for volume of 3D shapes. Please do add a comment below, and I will get back to you, and I look forward to seeing you inside the next video.